dancing is a dance form originating from Irish step dancing and clogging. First seen in America, slaves danced similarly to modern-day tap dancers. In the mid-1900s, tap dancing started getting much more popular. Dances were choreographed and people performed it on vaudeville and in other theaters. Tap shoes have stayed pretty much the same over time. Recently, tap dancing has been gaining much more worldwide popularity. What variables affect the sounds and moves the dancers make? Many different variables affect the final product of a dance. I'm going to use science and physics to explain this. A heavier shoe like this one will have a different sound than a light shoe like this one. The move will also be affected by the amount of acceleration the dancers put into it. For example, a heavier shoe with more acceleration will have a deeper sound than a lighter shoe with less acceleration. This is a display of Newton's second law of motion. Here's a light tap shoe. Compared to a heavier one. You've probably noticed a louder, fuller sound with the heavy shoe. Friction is a big part of the physics of tap dancing. Look at this clip, for example. Friction between the dancer's shoes and the floor prevents them from sliding or falling. Obviously, gravity also plays a role. In these jumps, you can see how gravity pulls the dancer straight back into the floor. Let's watch it again in slow motion. Watch how they go down straight into the floor. Gravity is the main reason for this, although the position of their bodies does have an effect. I'll talk more about that later. Gravity also creates more momentum going into the ground and a better sound. Inertia is a concept stating that any object in motion will stay in motion until an outside force acts on it. Look at this clip. The dancers move constantly in one direction until gravity and their bodies pull them down. Notice how they go at a steady speed over, across, and then down. This concept is also explained in Newton's first law of motion. Every object in a state of uniform motion tends to remain in that state of motion until an external force is applied to it. Action-reaction forces. This is explained in Newton's third law of motion. For every action, there is an equal and opposite reaction. Action-reaction forces have little effect on tap dancing. Centripetal force. Centripetal force is the force that is necessary to keep an object moving in a curved path and that is directed inward toward the center of rotation. Look at this diagram. Centripetal force really doesn't affect tap dancing. Kinesthetics, or body movements, affect all aspects of tap dancing. Look at this dance. Compared to this one. The first dance is done with a stiff upper body and without heels. This makes it less stable for dancers. Also, because this dance is not danced with the whole foot, there is more force over a smaller area. Therefore, more pressure. The second dance is done with a looser, more flowing body and more area of the foot. The loose body helps balance and control of the dance. By using the whole foot, there is more area the force of the body is pressing down on, so less pressure.
After 6 hours of school, I had enough for the day. I hit the radio dial and tuned it up all the way. I got a dance, right on the floor. Dance, right there on the floor. Really hard. Dance, now the beat's really fine. Dance, yeah. When I feel put down, I'm trying to shake it off good. And with my chick by my side, the radio doesn't chill. I love to dance.